and welcome to this edition of CU Science Update. I'm Ina Damuri. Over the past century, human beings have made extraordinary leaps and bounds in technology. We have also tripled the global population, 6 billion people and counting. Because of this process, we have created an unhealthy environment for our planet. Many scientists conclude that human-induced pollutants are contributing to a runaway greenhouse effect that is warming the Earth and changing the climate. In 2007, the United Nations Intergovernmental Panel on Climate Change won the Nobel Peace Prize. Several dozen scientists and support staff, both at the National Center for Atmospheric Research and here at CU, shared in this prestigious award. The IPCC report shows that the rapid changes in our climate is caused by human activity, and these changes will have an impact on our way of life. There are some skeptics trying to discredit the science of climate change by pointing out the recent heavy snowfalls in the Northeast as evidence against global warming. It's important to understand that the basic physics and chemistry of climate change is undeniable. Sunlight passes through the atmosphere and hits the Earth's surface. Some of the rays are reflected back into space while others are trapped by greenhouse gases such as carbon dioxide and methane. The trapped heat keeps us warm and cozy, otherwise we would be frozen. This greenhouse effect has been going on for millions of years, allowing life to flourish. But too much greenhouse gas in the atmosphere is not a good thing. It warms the planet too much. Because of humans, the level of carbon dioxide is higher than it has been in the last 420,000 years and still growing. So what are we to do? Have we passed the point of no return? Well, here at CU, we are doing our share to be more energy efficient and reduce greenhouse gases. We've taken great strides in recycling, using energy efficient light bulbs, adding solar panels to certain buildings, and even installing toilets that helps us save water. We are even renovating our dorms to be more energy efficient. CU Science Update reporter Rachel Dubrovin tells us more.
CU has definitely turned green. And it's one of the greenest universities in the country. Here at Kittredge, 2 dorms have already been renovated with new light fixtures, air circulation vents, and water-saving shower heads and toilets. Sensors have also been added to save energy. One sensor will turn off the heat when it detects a window is open. And motion sensors will turn lights on when someone enters a laboratory or study room. The sensors will turn lights off again after the room has been empty for a time. We spoke with our net resident, Elise Madital, about her personal views on conservation.
Being green probably means just not taking more than you should. I don't know how I would feel about being in a dorm where, I think a lot of them actually have, where the lights turn off when no one's in there and stuff, but it's easier and makes things better. It's easier to live with intention if it's kind of done for you.
Our net is one of the 5 dorms in Kittredge complex, and its renovations were complete in spring of 2008. Next door, renovations were complete a year later on Andrews Hall. Buckingham is getting renovated right now, and it'll be completed in spring of 2010. And next door, Smith Hall is getting an addition. When these projects are completed, they'll receive the LEED Gold certification.
If you come up with a building that from electrical usage use the ultimate methods, systems such as CFL lighting, from the heating system, from water conservation, from using recycled material in the building, ultimately give you a LEED certification.
In addition to receiving praise from the LEEDS program, the green renovations are also approved by the residents.
I feel like even if in 20 years we're proven wrong and that there's not climate change, I don't know why it would hurt you to spend less money or drive less or be healthier by eating organic or any of the other things.
But the renovations in Kittredge complex are designed to do more than just save money.
And also we're trying to make this part of the education for our students. Keep in mind, it's not that they live with us, they come freshman class, come live with us only 1 year. We are hoping in that 1 year we educate them so they end up to be better citizens of Earth for the rest of their life. Some of these ideas they're going to take with them, they're going to apply it to their life.
Climate change is not a recent phenomenon. It has occurred many times before. Climatologist and CU professor James White joins us in the studio to explain how climate change is happening faster than anything we have ever seen in the past.
Hi, Jim. Thanks so much for joining us for CU Science Update today. I understand you're a climatologist. Can you tell us what it means to be a climatologist?
Well, a climatologist is someone who studies the climate of the Earth. I happen to be a paleoclimatologist. I study the climate of the past in an effort to understand the processes that might be controlling climate change.
Okay. And what has your research shown you about climate change in the past?
Well, we've discovered a number of things about climate change in the past. One is that in order to really understand climate, you don't need to get too complex, particularly on a global scale. You need to know how much energy you get from the sun. You need to know how much of that energy is reflected by things like snow and ice, very reflective surfaces. And you need to know the level of greenhouse gases in the atmosphere. And those three things can actually tell you a lot about climate.
Okay. And in the past, we know that the climate has gone through a lot of changes, from the mini ice age to the medieval warming period. What caused those changes? Do we know what caused those changes?
Well, the medieval warm period and the little ice age are actually pretty small changes. We think that maybe a combination of a slightly warmer sun, more energy from the sun during the medieval warm period, with perhaps less sun during the little ice age, and maybe some extra volcanism. Volcanoes produce aerosols that go up into the stratosphere and also cool off the planet. That could have been part of the little ice age as well.
Okay. Are there other times in the past when we had major changes to the climate besides the medieval and the little ice age?
Oh, absolutely. If you look at the history of the climate over the last million years, it is the hallmark of that is huge changes in climate, where ice sheets covered most of North America, most of Scandinavia, sea level dropped by 300 feet, all that ice coming out of the ocean and making land ice. Temperatures on the planet dropping by 4 or 5 degrees Celsius, which is a lot. 4 or 5 doesn't sound like much, but it is a lot. This is the glacial, interglacial cycles, the big climate changes that we see over the last million years.
Okay. So those big climate changes, what was the reason behind them?
Well, the primary reason behind them was a change in the Earth's orbit around the sun, such that when we were farther away from the sun, we cooled off. And when we cooled off, it allowed these big ice sheets to grow. We also think that on top of that was the level of greenhouse gas in the atmosphere, particularly carbon dioxide. It's been declining over about 60 million years, and we seem to have reached a point where CO2 was low enough that the sun's influence on the climate began to be felt in a large way, and we went through these big glacial and interglacial cycles.
Okay, when there's changes in the CO2 in the past, what caused the levels of CO2 to change in the atmosphere?
Well, probably the biggest control on carbon dioxide is the ocean. Most of the free carbon on the surface of the Earth, or in what we call the surface of the Earth, including the ocean and the atmosphere, is in the ocean. So if the ocean changes its circulation pattern such that it more vigorously circulates and takes the carbon from the dead organisms that die and fall down to the deep waters, if those deep waters communicate with the atmosphere more frequently, then CO2 levels rise and the planet warms up.
Okay, so obviously today there's a lot of talk about climate change, and a lot of talk that this climate change is happening because of a rise of CO2 in the atmosphere. So if I'm a climate skeptic, how do I know that this rise isn't happening because of the ocean?
Well, in the first place, all scientists are skeptics. The way that we know that CO2 rise in the atmosphere is due to human beings is very simple. We look at how much carbon dioxide there is in the atmosphere, compare that to the amount of CO2 that we've derived from burning fossil fuels, and we realize that the increase that we see in the atmosphere is very easily accountable by the burning of fossil fuels. As a matter of fact, roughly half of the fossil fuel CO2 we put in the atmosphere finds its way either into the ocean or into land plants. So only half of it actually stays in the atmosphere.
Okay, and how much have we seen an increase in CO2 since the industrial age?
Since the industrial age, carbon dioxide has gone up by about 100 parts per million. So a part per million is 1 CO2 for every million nitrogen and oxygen atoms in the atmosphere. 100 may not sound like much, but 100 is the same change that occurred when we went from these glacial to interglacial cycles. So the largest climate changes in the last million years, much larger than anything we've seen in the last 10,000 years, we're accompanied by 100 part per million change in CO2, and that's what we've done in about 100 years, most of it in 50 years.
Okay, and how long did it take that 100 parts per million increase in the past?
In the past, it was thousands of years.
Okay.
It would take the ocean probably in the neighborhood of 4,000 or 5,000 years to change circulation enough that you could change the atmosphere by 100 parts per million.
Okay, so in essence, you're saying that we've caused the same change that the ocean took in 1,000 years in 100 years?
Yeah, we're about 100 times faster in terms of our production of CO2 than the natural system.
Okay.
We're impressive.
Yeah, it sounds like. And why should we be concerned about this dramatic increase in carbon dioxide?
Well, as I pointed out, if you change the amount of carbon dioxide in the atmosphere, you will change the climate.
Okay.
That's one of the 3 easy controls that we have on the climate system. So that we know that if we increase carbon dioxide, and we have done it, the planet will warm. There's more energy in the atmosphere. That's what climate is the energy in the atmosphere. And about half of that energy is expressed as heat. So the planet will warm up if we add CO2 to the atmosphere.
Okay, well, I kind of like warm weather, and you know, I wouldn't mind a shorter winter sometimes. So the planet gets warmer, why should I care?
Well, it's a very, very important question, and it's what I call the adult question. We need to move beyond whether or not climate is changing. Yes, it is. We need to move beyond whether or not humans are causing it. Yes, we are. To really, I think, very important, serious questions like that. What are the downsides? What are the upsides? We like to look in terms of cost and benefit at decisions that we make in society. I can come up with some very easy downsides to climate change, and there's certainly some positive ones. I'm like you. I'd love to see it be warmer. But when it's warmer on our planet, sea level rises. We built most of the major cities of the world using ships to populate the planet, basically. And so most of our big cities are on the coast. Miami, for example, sea level will go up by about 3 feet by the end of this century, by 2100. And it won't stop there, it'll keep going up. 3 feet of sea level rise will pretty much take out or inundate the majority of the greater Miami area. So cities like Miami, Norfolk, Virginia, Philadelphia, coastal cities like that, they don't have a future if sea level continues to rise, as it is today, as it will in the future.
Okay. Well, as someone who lives out west in Boulder, Colorado in the mountains, why should I be concerned necessarily, besides the fact that they are my fellow citizens, about what happens to the cities on the coast?
Well, I think there's 2 good reasons. You pointed out one of them there. They're your fellow citizens. Are we so callous and cold that we don't care what happens to somebody else? The other thing is that it's going to cost you. You pay taxes, right?
I do.
All right. Some of your taxes are going, for example, to repair New Orleans, which was hit by a hurricane. It's the same kind of situation. You may not live in New Orleans. None of those people may have come and moved into your neighborhood, but you pay to deal with that problem. So when those cities need to be rebuilt, and where they're going to be rebuilt will be a question, because the sea level will continue to rise. We continually have to rebuild them. It's going to cost all of us quite a bit of money to deal with that problem. And we have other problems that we'd like to deal with. We'd like to deal with Social Security, and we'd like to deal with health care. We're basically taking on costs that we don't have to take on.
So I think we've built a pretty strong case for why we should be concerned about climate change. So what would you suggest as a first step to go about addressing climate change, ways we could change our behaviors?
Well, I think first thing we do is we educate ourselves. I think that's very, very important to understand what are the ramifications. You know, as I said, what are the costs and benefits that go along with climate change? Because as individuals, we have to make decisions. We vote for representatives, and we need to vote for those people based on some solid information. If you just vote on them based on whether you like them or not, you're not really fulfilling your role and duty, I think, as a citizen. The other thing you can do, and I think the most important thing you can do, is contact your elected representatives and let them know how you feel. If you think that climate change is an issue and a problem, let them know, and let them know right away.
That is all we have time for today, and join us again for another edition of CU Science Update.